So looking in Unit 2, this is working with the calculator again in the TI-84. This is going to come from Section 3.4, additional topics, permutations and combinations. So I'm just going to introduce you to a little bit of using the calculator to do some things with factorials, and also there's a formula for permutations and combinations on the calculator as well that we take advantage of to kind of solve the problems a little bit quicker. So one thing you're going to come across is a permutation. So a permutation is an ordered arrangement of objects. So the number of different permutations of n distinct objects is defined as n factorial. So I have this little n with a little exclamation point. So we have what we call n factorial. So some things they talk about, n factorial just means n times n minus 1 times n minus 2 times n minus 3, all the way down to 3 times 2 times 1. So 0 factorial is just equal to 1. 1 factorial is equal to 1. 2 factorial means 2 times 1, which is 2. 3 factorial means 3 times 2 times 1, which is 6. 4 factorial would be 4 times 3 times 2 times 1, which would be 24. So if I want to do like 8 factorial, that would be like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Let's say it can get quite lengthy there. So instead of trying to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on a calculator, in your TI-84, if I hit the math button, notice if I scroll over, hit the arrow button, directional pad, to PROB, probability, there are some little shortcuts here. Notice that number 4 has the exclamation point. So if I want to do 8 factorial, what I can do is hit the 8, go to the math button, go across to probability, choose number 4. Notice how it gives me 8 factorial. If I enter, it'll actually do that math. So I don't have to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I also get the same thing. So that's just a shortcut of actually calculating that out. So in using permutations, we have, say this question here, the Big 12 is a collegiate athlete conference with 10 schools. So that's Big 12 has 10 schools in it. So 10 schools are Baylor, Iowa State, I should say, Kansas State, Oklahoma State, TCU, Texas Tech, and West Virginia. So we have all those schools. So the question is, how many different final standings are possible from these Big 12 football teams? So notice that what you're talking about, final standings, who finishes first, second, third, fourth, fifth, sixth, so forth and so on. So notice that, if I'm doing the math, there's 10 teams who could finish first, but once you have a team finishing first, there's only 9 teams that could finish second. How many teams could finish third? There'll only be 8 left there. 7, and then 6, then 5, then 4, then 3, then 2, then 1. You'd have to do that all together. But a shorter way of doing that is just use 10 factorial, and it'll do that math for us. So using my calculator, if I clear this off here, I can type a 10 in, and to get to the factorial, I hit the math button, use my arrow button to go to probability, and the exclamation point, the factorial symbol, is number 4. So I choose 4, and it gives me that. Hit enter, and it'll give me that number. So that'd be like 3 million, or actually, I guess it's, 3,628,800. That would be our number there. So that's what I'd come up with is, what was that again? 3 million. I have to look at that again. 628,800. So there'd be that many different ways for final standings. So actually, it's a lot more than you think. So that's what's called a permutation. There's also a permutation where you have n objects taking only r of them at a time. So you may want to choose some of the objects in the group, but not all of them, and you want to put them in order. So this is where you get into some ranking. So psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick first, second, and third? So the way this works is, we'd have, so the formula would be in PR. So I could say, n factorial means, n is the number of actual objects. So there's 10, or I'm sorry, there's 8 activities. So that would be 8 factorial on the top. On the bottom, you'd have n minus r. So that would be 8. And notice how there's a first, second, third. So there's like 3 different ways they're taken. So it would be like 8 minus 3 factorial. So this is going to be like 8 factorial over 5 factorial. So 8 factorial would be like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In fact, 5 factorial would be 5 times 4 times 3 times 2 times 1. So set the 5 times 4 times 3 times 1 will cancel out, and you would just have this 8 times 7, which is 56, times 6. And you'd have then 336. So you'd have 336 as an answer there. So instead of doing that math there, you could just use your calculator and just use what's called the permutation, where n objects taken r at a time are involved. So in there, what I can do is I type the 8 in to start with, and then I go to my math button. I scroll over to probability, and notice how number 2 is in PR. So notice how I choose that number 2, and notice how all I gotta do now is put my little choose 3 there, hit enter. Notice that it gives me that 336 without doing all that math. So it's kind of a shortcut. Okay. So that's that one. What else do we have here? So again, you actually can type in 8 objects chosen 3 at a time, and that would give us our 336 things. And notice how they're saying there is an ordering there. So there's 336 ways of ordering that. There's also this thing called distinguishable permutations, where there's n objects where n1 are of one type, n2 are of another type, so forth and so on. So I have this little formula, n factorial over n divided by n factorial times n2 factorial, so forth and so on. So if I was wanting to find the number of distinguishable permutations, where this would fit in is, we have a building contractor is planning to develop a subdivision. The subdivision consists of 6 one-story houses, 4 two-story houses, and 2 split-level houses. So notice how to find n, you'd actually have to add these up together. So 6 plus 4 plus 2, that'd be 12. So there's 12 actual things here. So it's going to be 12 factorial. And we're going to have that over, so notice how there's one type is 6. So I have 6 factorial. And then I have a 4 factorial. And then I have a 2 factorial. So I have in objects, there's 12 different houses, but 6 are of one type, 4 of one type, and 2 of one type. So what I can do is put that into the calculator. So I'll slide this over to the side like this. Get my calculator out here again. So to do this, they'll say I have a fraction. So that's the n over d button. So if I hit the alpha F1 button, they'll say number 1 is a fraction. So on top, I need 12 factorial. So I type the 12 in to start with. Hit the math button. Go over here to probability. Let me get this out. I can see. Over to probability, one more. And choose number 4 for that. And then go down the bottom, and I need 6 factorial. So I hit a 6, hit the math button, come across here to probability, choose number 4. And then I need a 4 factorial. So 4, and then my math button again. number 4, and then 2 factorial. And then hit enter, and that would give me 13,860. So that's going to be 13,860 ways to arrange that. Okay, so that's another type of problem you can put into the calculator. Another thing is we have what's called combinations. In combinations, this is where order does not matter. ABC and BAC are the same thing. So if order doesn't matter, that we call this a combination. So the number of ways to choose R objects from N objects without regard to order is called the combination of N objects taken at R at a time. So we have a formula here for that. So N with the CR. So the C stands for a combination. So we have this formula N factorial over N minus R factorial times R factorial. Now, instead of doing all that, we actually can just use the calculator and just use that as a way to calculate this. So say a manager at an accounting department wants to form a 3-person advisory committee. So let's say it doesn't matter how they're chosen. So order does not matter. It's just 3 people. They're not distinguishable there. So if I have 20 employees and he wants to choose 3 of those employees, what I can do is use, 20 combination, and I'm only going to choose 3. And this will be a lot smaller number since order does not matter here in regards to permutations. So if we use the calculator on that, so we had 20 to start with. Then I go to math, go over to probability. Notice number 3 is the combination one. And now I got to choose 3 and hit enter, and that gives me 1,140 different ways of doing that. So 1,140. So that's how we can actually use the calculator to do combination problems. So hopefully you find that useful, finding those keys on the calculator.